You know, your blood is so much more than just, well, the red stuff that shows up when you get a paper cut. It's actually a living diary. It's a story written by your ancestors, a story of survival, migration, and adaptation. So let's get into it and uncover the secrets that are literally flowing through your veins.
For centuries, the idea of moving blood from one person to another, it sounded like a miracle cure, right? But in practice, it was a terrifying gamble. Early doctors, they tried everything, mixing blood between different people, and get this, even between animals and humans. The results were pretty disastrous.
Yeah, listen to this chilling account from way back in 1667. It describes a patient's reaction after being given sheep's blood. It's just a stark, horrifying reminder of the deadly mystery doctors were up against. The patient's body was violently rejecting this foreign blood, and absolutely nobody knew why. Figuring this out was truly a matter of life and death.
So, the key to finally cracking this code came at the turn of the 20th century, and it was thanks to an Austrian physician named Karl Landsteiner. He had this hunch. He suspected the problem wasn't that the blood itself was bad, but that different kinds of human blood just weren't compatible with each other. And so he started a series of really simple experiments that were about to change medicine forever.
Landsteiner's discovery in 1901 that some blood clumped together when mixed, that was the big aha moment. This discovery led directly to simple pre-mixing tests, and then later we figured out anticoagulants like sodium citrate, which totally paved the way for the blood banks we all rely on today. Suddenly, a deadly gamble became a routine, life-saving procedure.
So what was actually causing that deadly clumping? Well, it all comes down to two key players. First up, you've got the antigen. The easiest way to think about it is like an ID badge that every single one of your red blood cells wears on its surface. It's basically telling your immune system, hey, I belong here, I'm one of the good guys.
Okay, so if antigens are the ID badges, then antibodies are the security guards. These little proteins patrol your plasma, and their whole job is to check those IDs. If they spot a cell with a foreign, unrecognized ID badge, they immediately sound the alarm and launch an attack.
And this is exactly where things go wrong in a bad transfusion. See, if you have type A blood, your security guards, your antibodies, are trained to attack any cell wearing a B ID badge. And if you have type B blood, it's the complete opposite. So when you mix them, the security guards from one type see the other cells as hostile invaders, and boom, that's what triggers that deadly clumping reaction.
But here's where it gets really cool. Blood types are so much more than just a medical label. They are an evolutionary fingerprint. They tell the story of how different groups of our ancestors survived completely different challenges over thousands and thousands of years. Each blood type carries its own unique legacy of advantages and, of course, vulnerabilities.
Just take a look at this global breakdown. You can see right away that type O and type A are by far the most common. Meanwhile, B and AB are much, much rarer. And this isn't just some random pattern, no way. It's basically a map of our human past, one that's been shaped by disease, diet, and migration.
Let's start with type O. It's widely considered the original blood type, kind of the default setting for our earliest hunter-gatherer ancestors. Its free-flowing nature means you've got a lower risk of nasty things like blood clots and heart disease. But there's a trade-off. That same quality left a vulnerability. It's actually easier for the bacteria that cause stomach ulcers to latch on.
Now, let's talk about type A. This is the blood of the first farmers. As humans started settling down into crowded towns and cities, brand new diseases started to pop up. The A antigen is thought to be a kind of immune system upgrade against those new threats. But again, the trade-off? That sticky quality of the blood increases the risk of clots. And interestingly, people with type A are biologically wired to have a more intense cellular response to stress.
Type B, on the other hand, tells a story of constant movement. It's the nomad's blood, most common along ancient migration routes. All that traveling forged a really specialized immune system that's great at fighting off certain kinds of bacteria. The downside? That finely tuned system can sometimes overreact, which leads to a higher risk of autoimmune disorders.
And that brings us to type AB, the modern blend. It's the newest type on the block, and it came about from the mixing of A and B populations. Its superpower is being the universal recipient, pretty cool. But its super welcoming immune system can be a little too tolerant, making it more vulnerable to certain infections and, surprisingly, to a significantly higher risk of cognitive decline later in life.
So, knowing the story behind your blood is fascinating, but knowing the rules of transfusion, that can save your life. It all comes back to those antigens and antibodies we talked about.
So let's break down exactly who can give blood to whom.
Okay, this chart right here is basically the rulebook for safe blood transfusions. Now, you don't need to memorize the whole thing, but pay close attention to the two real superstars here. O negative up at the top, the universal donor who can give to literally everyone, and AB positive at the bottom, the universal recipient who can take from everyone. Let's dig into why they're so special.
O negative is the absolute hero of every emergency room. Why? Because its red blood cells are completely blank. They have no A antigens, no B antigens, and no Rh factor antigens. They're basically biologically anonymous. This means no immune system anywhere will recognize them as a foreign threat. That's why every single unit of it is treated like liquid gold.
AB positive is the total opposite. Its red blood cells have all the major antigens, A, B, and the Rh factor. And because its own immune system is already familiar with all of them, it sees every other blood type as friendly. It's like the ultimate biological welcome mat.
But you know what? The story doesn't even end with these 8 common types. Not even close. The world of blood is far, far stranger and more diverse than most of us could ever imagine, both in humans and all across the animal kingdom.
Take AB negative, for example. It's the rarest of the 8 main types. We're talking less than 0.5% of the entire global population. To put that in perspective, you are more than 80 times more likely to be O positive. It's a true statistical ghost, right at the absolute edge of human variation.
But nature's color palette goes way beyond just red. Horseshoe crabs? They have blue, copper-based blood that is absolutely essential for vaccine safety. Some lizards have bright green blood. Certain marine worms have purple blood. And get this, ice fish in the freezing Antarctic have completely clear blood, surviving with no red blood cells at all.
So the next time you see a drop of blood, just remember what you're really looking at. It's a medical key that unlocks modern medicine. It's a historical diary written by your ancestors, telling you exactly how they survived. And it's a unique evolutionary fingerprint that connects you to an ancient, unbroken chain of life.
And this story, it's not over. For everything we've learned, scientists are still chasing that next great frontier, creating a truly universal, fully synthetic blood that could one day make blood types a thing of the past. So you have to wonder, what other secrets are still waiting to be discovered right there in our own veins?